That's embarrassing. All right, dude. We are live. What's up, guys? This is Dem Keys, and today we're going to continue learning about Git branching. I'm gonna try and keep the yap sesh to a minimum. The yap sesh that I do at the beginning of my streams usually. I'll try and keep that at a minimum. Give me a second. I think I need to reposition my mic a little better. Check, check, testing, testing. Yeah, I think we're good. Okay, so um between yesterday and today, I've been doing a couple of things. I actually I've been busy with a bunch of different things, so I can't really even remember what all I've been up to. I was having a couple of conversations with Gemini, where Gemini was explaining a bunch of different things to me. One of the conversations I was having was about subprocess.run, which is basically a way of running programs from within your Python script. However, it's different from, sorry, it's different from running the program in your shell. And how exactly it's different is what I was trying to understand, because apparently the difference there also makes it more secure than the other method, which I believe it was p open or something like that. I think so. I don't remember exactly. But yeah, I was having that conversation with Gemini. I was also discussing this thing actually that you can see on screen. This Python code is showing, hold on. Yeah, this Python code is showing something called implicit concatenation, I think it's called. Basically, the idea is that if you have, let's say, a string and the string is really long, then you would be writing, let's say, if I try to write this out as, wait, that's a comment. There. If I try to write this out, it'll be this is a, wait, hold on. Let me just yank this and paste it here. And delete this. There. So if I did this, then I would be doing it in this way. So this would be the long string that I have. I could enable wrap in NeoVim to wrap the line, but then there's other issues with that. Like for example, if my code starts to get longer, then that's going to be wrapped as well. Honestly, when it does get longer, you kind of do want to wrap it manually, but when it's wrapped, through NeoVim itself, if the code is itself is being wrapped, it's going to look a little weird. So instead of that, you could use this concatenation method where you just wrap multiple string literals, which are like on individual lines. You wrap this entire batch of literals within parentheses, and Python just considers that entire thing as one string, which is super convenient because this way you can write everything that fits within your screen in one line, and then when it's not fitting anymore, you can go to the next line and the next line and next line and so on. It's also very convenient for wrapping expressions or breaking up expressions into multiple lines. Like this one, for example, this is a conditional expression where I'm saying, if so-and-so variable is greater than this value and so-and-so variable is greater than or equal to this value, and so-and-so variable is less than this value. Right, all of this could have been written on one line, but that would be a very long line, and it's not the best to read. So you could then wrap it up in this way. Though, okay, there's something worth mentioning. In certain cases, the formatter does do the wrapping for you. Also, I believe the formatter itself does this, the parentheses thing, because I tried doing this with a very long arithmetic expression. And when it was short enough to fit on one line, then the entire expression was put within one line. Even if I decided to put it up in, even if I decided to break it up into multiple lines, the formatter would just squash everything and put it into one line. However, if I made it long enough, then the formatter itself would would break it up into multiple lines and wrap it in parentheses. And I looked this up. The parentheses is actually, it's a Python thing. It's a Python standard now. Previously, we had this thing where you could add a backslash at the end of the line, and that way you could break it up into multiple lines. But then that had certain other issues of its own. This syntax is a lot cleaner and somehow just better. I haven't gone into the details of how how it's better, what the specifics are. What I do know is that this method works, and honestly, this looks better than the that whole backslash thing, because this, if you are looking at it in this way, then you can see that, oh, there's parentheses here and there's no commas at the end of each of these lines, so it's basically one expression. Um, but yeah, that's one of the things that I've been busy with. Another thing I was busy with was this, where I was reading how subprocess.run works. I'm not going to be I'm not going to be reading that on stream. I'm leaving that for off stream. For on stream stuff, I want to focus on Git, because we were looking into Git branching. Give me a second here. Let me open up my stream on my phone so I can see the chat. Now, once I've set up this logic, I'm actually excited to see what the end result of this is going to look like. I'm definitely gonna run some of my clips that I have. I don't remember if I have I don't remember if I've been deleting them, because I was deleting for, space purposes, but I was also transferring them to a different machine because of how my workflow is, and the transfer wasn't really much of an issue. I was mainly using SCP to transfer it over SSH, and hopefully I have a couple of clips. Some of the clips were actually long enough. Um, they were, let's say, 5 minutes, anywhere between 3 and 4 minutes. So even 3 to 4 or 5 minute clips, I can run them through this silence detection script and see what I can get out of it. Though I'm not too comfortable with doing it on those clips that I exported, solely because I exported those clips using um, the lazy method, and the lazy method does leave a tiny bit of a mess within the metadata of this video. Be it in the video metadata, or the video section of the metadata, or the audio section of the metadata, it does leave a bit of a mess there that hasn't been regenerated properly or cleaned properly or just recalculated properly. There are some issues there, timing related issues, and what I'm doing here, it heavily relies on timing. So just at the off chance that there ends up being some sort of issue there, I would actually, you know what? I could run those videos through the script, and if there's going to be issues, I guess I'll find out, right? Yeah, I guess I'll find out if there are actually going to be issues. So that way I'll know that, hey, so and so clip is so and so. I forgot where I was going with that. That way I'll know that so and so mechanism doesn't work with the silence detect script. I'm hoping it works though, because that makes it so I'm able to do that would make it so I'm able to run the clips directly through, as in the clips that are produced from the lazy extraction script. I'll be able to run those clips directly through the silence detect script. Um, the thing is though, whenever I do that, do do, whenever I do that, I so initially I was hoping that I would be able to, re-encode the entire thing, but that was mainly if I were pulling it out of the original VOD, because in the original VOD there's encoding, and so when I'm pulling out clips using the lazy method, specifically the beginning and the end of the clip could have glitches. It's not necessarily going to have glitches for sure, but it could. And the glitch might just be for a couple of frames or something. So it's not that big of a deal, especially if it helps with, producing clips on a much larger scale, much faster. I don't mind that tiny bit of a glitch because these are clips that honestly, once I post them to social media, I myself am just going to forget about them. And anybody who watches those clips, it's not like they're going to be constantly coming back to the clips. So I don't think I need to put so much effort and so much focus and so much value into those the tiny like glitches that might be there, tiny details of these clips that are meant to be just quick consumption content that somebody is going to scroll away from in the next, I don't know, 10, 15 seconds. Basically, what I'm saying is because I've done this in the past where I put a lot of time and effort into details that don't matter. That's the best way that I can put it. In the past, I've put a lot of time and effort into details that mattered to me, and like they matter to a certain extent. Okay, I'm not going to say that they completely don't matter. They matter to a certain extent, but at a certain point, you have to realize that a lot of these details, you're the only one noticing them. And even if you're not the only one noticing them, and there are a few other people noticing them, there's a good chunk of those people that don't give a shit about those minor details. They'll look past it because again, this is meant to be short form content that somebody's just going to scroll away from in the next 15 to 30 seconds. So that's why I need to I need to keep reminding myself not to get too bogged down with the details. Otherwise, I'm going to waste a lot of time and accomplish very little. So if I want to make progress, I need to keep reminding myself that hey, these are tiny details. Let it go. It's fine as long as things work. As long as you're able to produce content out of this, it's great. It if it works, then just leave it alone. So, after I've learned, because I'm currently learning about subprocess.run, I'm gonna go with Gemini's idea because I'm very heavily taking help from Gemini. Hold on. Yeah, I'm very heavily taking help from Gemini for this. Um, so I'm gonna run the script as Gemini is telling me to. I have the probe command set up. Oh, I actually don't have the probe command set up. Yeah, yeah. If I go into um if I go into the script here, oh, I don't think I've written the script anyways. This is the script so far. I don't think I've written the entire script, or I think this is the entire script. I haven't run the entire script. I haven't finished writing the remainder of the script because this is the command itself. The command is gonna run, and then I believe the output has to be captured as well. This is going to output JSON, and then that JSON is what we're going to be deserializing to get our data. Based on that data that we get, we then have to form an ffmpeg command to extract that specific section of the. Oh, actually, no, sorry. Let me say that again. We need to use the ffmpeg command to extract those multiple sections from the bigger VOD and then stitch them together and re-encode the entire thing. So all of this has to be done in one command, and that is why I want to do it directly from the VOD. Now, this detail would change a tiny bit if I directly feed a clip that's been extracted from the lazy extractor. If I directly feed that clip into into sorry, zoned out. If I directly feed that clip into this script, then that bit of detail is going to change a little bit, because then I'm not feeding the entire VOD and telling it, where to from where to where it's supposed to do this, the silence detect, and then based on that silence detect, from where to where it's supposed to be pulling out sections from this big VOD. Instead of that, I'm going to be feeding this clip that was extracted in using the lazy mechanism. I'm going to be feeding that clip in, and then I'm going to be telling the script to pull out sections from this clip and then stitch them together and re-encode the entire thing. But because this has been lazily extracted to begin with, I don't know if that's going to cause problems. Um, if it doesn't cause problems, that is a huge, huge bonus for me. That is a massive bonus, because then I don't need to worry about, like, I don't need to change my workflow too much. It'll be a lot more fluid. As soon as I run the lazy extractor, I do need to change the prompt to mention that instead of 30 seconds to 10 minutes, it should be anywhere between 3 minutes and 10 minutes. So that way I can expect every single clip to be a couple minutes long. Even if it's only 3 minutes long, that's fine. But I can expect every single clip to be a couple minutes long, and I can go through the clips and see what all is being talked about, and there'll be a lot more content in one clip. I do tend to have these situations where I have to stitch multiple clips together. So I am gonna have to see. Oh, you know what else I could do? So the thing is, okay, once the manifest is read and the clips are going to be extracted, before that, what we do is we write all of that manifest data to a new file called index clip manifest. That is this file, and that's basically the exact same data that the other clip manifest file had originally, except for one difference. Every single dictionary now has a key called ID, and that's what we use to name every single file. So you can see, um, hold on, where here, actually, exports. Yeah, so you can see here. What was I saying? Yeah. So you can see in the file name here, there's a number at the beginning of each file name. This is the ID, basically. So this is what the ID is being used for. Why was I talking about this? I forgot why I was mentioning that this is. Oh, yeah. Well, I go through these clips, and if I find a clip that I like, then I go back into the clip manifest and I look at the time for it. And like if I feel like there's multiple clips that could be stitched together, I'll look at, let's say if I have three of these clips consecutively, right? There's hex dumps something something, sensors for robotics, and then powering high current robotics. Let's say for whatever reason I determine that these three clips, they might be short enough and they might have similar enough info that I could stitch them together. So from further from that point, what I'll do is I'll note down the time, the start time of the first clip and the end time of the last clip, and then I'll craft a new ffmpeg command to just pull out that entire section as one video. So all three clips will be stitched together. Anything that's in between all of them, all of that comes within one clip. And I'm planning on following that exact same workflow even here. The only difference is once I've pulled that clip out, I'm going to feed that clip into the silence removal tool and pull out the silence from it. What I could do is, since I have the start time and the end time for all three clips together, I could feed the start and end time into the silence removal tool. Or in the beginning, I could extract the thing just to see what the video looks like. And then as a last step, I could then feed that time into the silence removal tool, but aim the silence removal tool directly at the VOD. So then what the silence removal tool would do is it would read directly from this VOD and then pull out the timestamps of silence start and end, and then within the script, dude, I just remembered I said that I wouldn't have a very long yap sesh, but here we are. But yeah, so it's gonna the at first it's gonna the tool is gonna determine the start and end of silence sections. Once that has been determined, then we kind of invert that. So we don't want those sections. We want everything else that's within this time range that we have specified, right? So it's just some simple math that I have to do there to instead of pulling out the silence sections, pull out everything else that has not been detected. And then all of that is, and okay, I'm mentioning pulling out those sections. I'm not going to be pulling it out. I'm going to be mentioning those timestamps that, hey, do it from here to here and do it from more or less. I don't even need to do math, honestly, because if I have, let's say, three silence sections, right? Um, start one, end one, start two, end two, and start three, end three. These are three different silence sections that we have, and each section has two markers, a start and an end marker. So we can ignore start one, or we can get everything that's before start one, but up to the point of the very beginning of the clip. And then end one to start two is our video segment. So we don't want everything, we don't want anything that's within start one and start two. Sorry, start one and end two. So start one and end two? No, we don't want everything, we don't want anything that's within start one and end one. So we don't want the entirety of the that silence section. What we do want is from end one to start two. That's our video section that we want. And then from start two to end two, we have another silence section, so we don't want that. But from end two to start three, we have another video section that we want. So this is how we determine the sections of the video that we want, and we feed all of that into the ffmpeg command. And then the command is then gonna, in this case, we're going to be doing the re-encoding method. We're not going to be doing the lazy extraction method. I guess the lazy extraction method would It works well specifically for determining the timestamps. So now my workflow is going to look a little bit different once I've set up this silence detect mechanism. Um, so we are basically going to pull out the sections that don't have silence, or we're going to tell FFmpeg about the specific sections that we want from the video, and then we're going to use a proper method which decodes the video first, then seeks up to that portion in the video, and then reads all of those sections that we have specified, stitches them together, and then re-encodes all of those sections into as one big video. So then we get a nice, good quality export out of that. Now that's the idea. And once I've set that up, that's going to be a huge upgrade to the the content pipeline. Once I have the silence detect thing set up, it's going to be a huge upgrade. This is assuming things go the way that I'm hoping they'll go. I have to see what the quality of the output is with silence detect. There's like a lot of intermediate stuff that's going on here, which makes testing in between a little hard. Because, for example, FFprobe's output is going to be in JSON, but FFprobe is giving me the silence sections, right? I then, based on those silence sections, I have to determine the other sections, as in the non-silent sections, what the non-silent sections are. And then I have to tell FFmpeg that, okay, these are the specific sections I want you to read from the video after you've decoded the video. These are the specific sections I want you to read, and then stitch them together and then re-encode it and export the final video for me. So in between all this, I feel like debugging this step by step is going to be a little hard because there's a lot of intermediate data in between. It's not like it's producing any videos in between these steps. So it might get a little bit complicated. I'm just hoping that the settings that Gemini has given me, it's mainly about it's mainly about two things. One is telling telling FFprobe what level of audio, um, or beneath what level of audio should we consider it to be silence. That's one thing. Like, what is silence here? That's what we have to tell it. And additionally, how long this silence has to persist for before you start considering that to be a silence section. These are two very important variables that I'll have to experiment with. If the initial values that Gemini has given me don't seem to work out, then I'll have to experiment with this. I don't think I'm gonna have an issue there, because a lot of like, okay, if I'm looking at the meter here, I think this meter does a similar thing. If I look at you guys can't see it because like I'm looking at OBS. In OBS, I have my audio meter, and it is showing, I believe, because I always get confused with these different audio, these decibel values or these decibel meters, because there's different types of meters that solve different purposes. But then in a digital form, you're given these different meters as different options because you might have different purposes. And so I always get kind of confused about how each of them works and what I should be looking out for. In my case, 0 is like the absolute loudest. Anything above that, the audio is going to start to clip. And in fact, by the time you reach to that point, already your audio is getting dangerously close to clipping. So you're already in like the red zone. Um, if I'm getting these values right, I think from 0 to 8 is the dead zone, or 0 to 10 is the red zone, not dead zone. Is the red zone. And then from 10 up to I can't tell what that is. 20, 22. I don't know. That's the yellow zone, and then everything below that is the green zone. So what Gemini has suggested in terms of values is negative 30 dB. So I'm guessing anything that's beneath negative 30 dB is gonna be considered silent. So I need to see where on this meter 30. This is actually convenient for me because I'm looking at the meter, so I can then change the value based on that. And I usually try to keep my audio well within the upper limit of the yellow zone. And I prefer for it to go slightly into red, but not way too much into red. So I know for sure that my audio most of the time is going to be above negative 30 dB. Dude, we need to get to the Git stuff. I've been yapping for 31 minutes and I just lost track of time. Hopefully, today I'm now like further from this point, I'm going to be able to do at least an hour and 15 minutes worth of Git studies. And I'm hoping that we get a bunch of studies done here. All right, so let me take a sip of water and then we will start learning about branching. Hopefully, the knowledge that I already have of branching is going to be helpful. So I won't be learning everything from scratch, but there's quite a bit that I don't know about branching. Like I mentioned in yesterday's stream, I know very basic branching. I know how to create a branch, switch to a branch, so check out a branch. I know a little bit about merging branches. That part I still need to learn a lot. I know about remote tracking branches conceptually, and I know that, when you fetch data from a remote, you're fetching the branch. Um, and when you merge the remote tracking branch, and when you merge, basically, you're merging the remote tracking branch into your local branch. Likewise, when you push, you're pushing a branch, you're not pushing commits. Pushing the branch pushes all the commit objects that relate to that branch. So I know this much about branching, but there's still a lot that I don't know about branching. So I want to kind of solidify my knowledge of branching, kind of like how now I can confidently say that I understand how um, how Git records changes, how Git stores commits. Previously, I didn't even understand that. I couldn't have confidently said that I understood, what commits are. I had no idea what, tree objects are, what blobs are. I, I didn't know any of that stuff. Now I do know it. So um, I guess that's a benefit of us having gone through the basics again. Okay, anyways, wait, give me a second. Let me hydrate and then I'll start reading. Okay, all right. Um, I don't think I need to create like a new project for this purpose, but I mean, I have some repo O2, don't I? And what's going on with the data here? What files do we have in here? Okay, okay. This is perfect. This is actually perfect. In fact, whatever changes we've made here, we can commit these changes. Um, Ninth commit, let's say 10th commit. Oh, also apparently there's a branch for this. There's a remote for this. What's the remote? I need to check that. But yeah, let's make our 10th commit. Git remote show. Okay. Git remote show origin. Okay, yeah, there it is. So this is a local thing. Yeah, yeah. This is a local repo that I've set up, and it seems to be in the same. Oh, what did I just do? Yeah, okay. It seems to be in the same um, parent directory. So if I come back here, didn't mean to do that. There, if I come back here and I do cd some repo, actually, some repo central git. Yeah, yeah, it's in the same directory. All right. Dude, I love Zoxide, dude. It is so convenient. The amount of times I've mentioned that I love Zoxide, it should tell you how many different little things that I had to do in the past that now have become so much more streamlined, so much more easier. There's so many different things that I had to do that they were tiny things, but they made the workflow a little bit hectic. And now it's much, much better. I guess I can open up NeoVim here, and I don't know what was the last session. Okay, good. I have all the files open here. We can do our commits from here. Okay, yeah. So let's start reading. Okay, Git branching. Branches in a nutshell. Nearly every VCS has some form of branching support. Branching means you diverge from the main line of development and continue to do work without messing with that main line. Okay. In many VCS tools, this is a somewhat expensive process, often requiring you to create a new copy of your source code directory, which can take a long time for large projects. Some people refer to Git's branching model as its killer feature, and it certainly sets Git apart in the VCS community. Why is it so special? The way Git branches is incredibly lightweight, making branching operations nearly instantaneous, and switching back and forth between branches generally just as fast. Unlike many other VCs, unlike many other VCSs, um, Git encourages workflows that branch and merge often, even multiple times in a day. Understanding and mastering this feature gives you a powerful and unique tool and can entirely change the way that you develop. Great. Okay. Branches in a nutshell. To really understand the way Git does branching, we need to take a step back and examine how Git stores its data. As you may remember from what is Git, Git doesn't store data as a series of change sets or differences, but instead as a series of snapshots. When you make a commit, Git stores. I just remembered that I didn't make those knowledge base entries that I had to make. Dude. The problem is, I've been waiting to finish making the knowledge base tool so that I can then use the knowledge base tool to build these entries. Because the thing is, the knowledge base tool is going to be creating the MD file and the directory. It's going to create the directory and the MD file within the directory. And in the MD file, it's going to create the front matter and put that at the very top of the file. That's that's all the KB tool is going to be doing in terms of creating an entry. I then have to open up the entry in NeoVim and type out all of the stuff, or in my case, paste the stuff because I've already typed everything out. And also I have to store the images and stuff, and link the images properly. I think what I'll do is I'll create the knowledge base entries, and later on, once I've created KB tool, I can then edit these knowledge base entries to have the, what do you call it, to have the front matter. So I can, maybe what I could do is I could create a tool to update. Yeah, I could do that. I could create a tool to update. I actually don't want to be able to update the, yeah, no. I'll just manually put the front matter in there. The few entries that I've made before building KB tool, I'll just manually edit them because it's just front matter that has to be added. So it's a tiny bit of extra manual labor that I have to do. It's not a very big deal. I just need to be careful of the formatting that I'm doing there. Little details here and there can make a difference, like in what format is the date being stored, because I have to make sure that the format in which I'm entering the date is the same format in which my KB tool is going to be entering the date. So is it date, month, year? Is it month, date, year? Which for some reason that's a thing. Is it year, month, day? Not even date. Year, month, day. There's this stuff like that. Then there's also for tags. I'm trying to set it up so it's going to be a comma separated list of tags, but there's no spaces in between there, and there shouldn't even be spaces between each of the tags. There shouldn't be any spaces anywhere. It's just a comma separated list of tags. Something that I could do is I could write some code to some validation code that would strip out any spaces that are added there. I could take it a step further and check if there is a space, right? If there is a space, is there a comma before or after the space? If there is, then just remove the space. However, if there's a word both before and after the space, that means somebody entered, well, somebody is me. That means somebody entered a multi word tag and they added a space in there. So we can replace that space with a hyphen. I don't want to do that though. I don't want to have those kinds of tags. I prefer to have just single word tags, like one word kind of things. But yeah, that's a bit of manual work that I'll have to do, which I'm okay with that. Okay, when you make a commit, Git stores a commit object that contains a pointer to the snapshot of the content you staged. The snapshot would be basically the tree, right? Because the commit contains a pointer to the snapshot. What it contains is a pointer to the tree. Sorry, zoned out. Okay. The object also contains the author's name. Hold on. Oh, the commit object. Yeah, the commit object. Because I read object and I was like, the snapshot doesn't contain that. But no, it's talking about the commit object. Git stores a commit object that contains a pointer to the snapshot of the words. Oh my God, of the content you staged. This object also contains the author's name and email address, the message that you typed, and pointers to the commit or parent stuff. Okay, to the commit or commits that directly came before this commit. That is its parent or parents. Zero parents for the initial commit, one for a normal commit, and multiple parents for a commit that results from a merge of two or more branches. This reminds me, I do have one situation. I do have one situation where, oh, there wasn't it wasn't a merge. It wasn't a merge. What was the project anyways? It was the dumb programs project. Hold on. Real quick. Rust dumb programs, Git UI. Yeah, there's a merge here. 693E 7A7. 693E 7A7. Let's just echo that. So to see the commit, how do I do that? ls file. I think it's ls files. Yeah, ls files. I want to see the commit of this. Hopefully I'm doing this right. Okay. No, can't do that. How? Oh, was it P? No, it wasn't. What was the method for hold on. Let me ask Gemini. Hey, hey, I'm sorry, zoned out. Okay. I'm uh I'm okay, hey, I'm I'm doing Git stuff. How do I look at the details of the commit object belonging, oh, object based on its hash? Oh, it's cat file, not ls files. It's cat file. Wait, let me just, okay, I think it's p. There it is. So we can see here two different parents, and this is the example that I was looking for, where we have two parent hashes because this was the result of a merge. It says merge remote tracking branch into main. Which remote tracking branch did I merge? Oh, I pulled main from remote, and then I merged it with the current main, which I had already renamed to main at that point because this specific repo, I had this issue where the first the very first branch that was made wasn't main, it was master. And that became a problem because on GitHub, when you create, because that's now the new naming convention, and it's been around for probably more than a decade, I think. I don't know. Either way, it's more common to use main now, not master. And so when I created the repo on GitHub, which was supposed to serve as the remote for this repo, it created a branch called main on there, but my repo here had a branch called master. So when I added that repo as a remote to this repo and I did git push, instead of pushing master, sorry, instead of actually I think I did git push master specifically. I don't remember how I went about that, but I did a push and it pushed master. I don't remember exactly what I told it to do. I only had master to push anyways, so either way I would have manually set it to push master. I wouldn't have told it to push main because at the time I didn't realize that there was this bit of discrepancy going on there. Sorry, zoned out. At the time I didn't realize that there was this bit of discrepancy going on there. Um, and so when I did the push, what I ended up with on the GitHub repo was two branches, main and master. And then I had a bit of a cleanup to do. So this was part of that cleanup. Pretty much what I did is I renamed master locally to main. And then I pulled from the remote main and merged the remote main into this main. Fortunately, the only thing that I had to merge really was just the license file because it was an empty repo at the time. And I believe that's what this merge was. I guess if we take a look at, I wonder how we're going to be seeing I guess it just adds the license file into the tree, right? So if I do ls tree A16441, yeah, you can see license in the list here. Whereas if actually, we can explore both of these other parent commits as well, right? Let's try cat file p B15455. Add project along with so and so. Let's try the next one. 33480. Hold on. 33480C. I don't know what that is. Hold on. Hold on. What just happened? I need to Google this real quick. Give me a second. Wait, what was the thing that I ran? Yeah. Okay. Okay. So I was sorry, I was asking Gemini about this thing that I just saw. So Gemini is saying that massive block of text is a public cryptographic signature. Oh, this is the what do you call it? Public private key encryption method. Yeah, I forgot what that thing is called. I even forgot how the thing works. But there's a thing where you expose a public key that is supposed to be known, and then you have a private key that no one is supposed to know about, which you use for decryption. But it's a little more complicated than just that. I think there's like handshakes that happen in between. I should revisit that. I never actually, this was like years ago that I looked into it, and I didn't go too deep into how the thing works. Even to whatever extent I did go deep back then, I've more or less forgotten everything. Okay, it's a public cryptographic signature proving that the commit was verified. Why is there a PGP signature in your commit? When you or a platform like GitHub cryptographically signs a commit to prove its authenticity, Git embeds that signature directly into the commit's metadata. When GitHub automatically creates a merge commit, for example, when you merge a pull request via the GitHub web UI or sync branches, GitHub signs the GitHub signs that merge commit using its own Webflow PGP key. When you ran git file so and so, you told Git to show you the raw, unedited contents of the commit object for a signed commit that includes the tree hash, the parent commit hashes, the author and committer info, and the GPG sig block. That's the massive PGP signature that you saw. This is safe because it's a public signature. A PGP signature is designed to be public. It is generated using a private key, but the signature itself is just mathematical proof that the person with the private key authorized the commit. No private keys are leaked. Your private SSH keys, GPG keys, and GitHub passwords are never words. Oh my God, are never stored inside a commit object. And then anyone can see this anyway. Anyone who clones your public repo or looks at the commit on GitHub can see this exact same signature by running the same command. Okay, cool. What a signed commit looks like. So let me run that again. Yeah, this is the data. So this is the thing from GitHub. And it also, oh, I'm noticing this just now. It also mentions committer GitHub. The other thing, which is not this. So these are the two, what would be a good way to like think about this? Because this is one parent hash, right? And then the other is another parent hash, and then both of them were merged together to create, damn, I cleared that. They were merged together to create, let me just keep going back. Was it this? Yeah. Um, both of them were merged to create this commit. Okay, okay. All right. Let's continue reading here. I forgot why I was doing this. Oh, it was to look at the two parent hashes because in the past I've never seen two parent hashes. So that's interesting to see now. Okay, carrying on. Where did we stop? The message you typed, pointer so and so, so and so, so and so. Okay, multiple parents for a commit that results from a merge of two or more branches. I didn't know that you could merge more than two branches together. So that's interesting to know. Okay, all right. When you create the commit by running git commit, Git checksums each subdirectory, in this case, just a root project directory, and stores them in a tree object in the Git repository. Git then creates a commit object that has the metadata and a pointer to the root project tree. Sorry, zoned out. And you probably heard me doing my knuckle popping thing. Anyways, where was I? Git checksums each subdirectory and stores them as a tree object in the Git repository. Git then creates a commit object. Oh, this is basically like the entire process of like creating that snapshot and then creating the commit object, and the commit object points to the snapshot and also gives extra details like the author and a commit message and a parent hash, a parent commit. Okay, Git then creates a commit object that has the metadata and a pointer to the root project tree so that so it can recreate that snapshot when needed. Okay, your Git repository now contains 5 objects, 3 blobs, each representing the contents of one of the 3 files. Dude, I remember going over this in the past and saying that I'm glad that I looked into that whole, Git objects thing by myself, because I feel like I went into a lot of detail there. And, sorry, and sorry, um, man, I choked and I forgot what I was trying to say. I went into a lot of detail there, which I don't think I would have gone into if I was learning it from this. Yes. Okay. All right. Great. Your Git repository now contains 5 objects, 3 blobs, each representing the contents of one of the 3 files, one tree that lists the contents of the directory and specifies um, which file names are stored as which blobs, and one commit with the pointer to that root tree and all the commit metadata. Sorry, zoned out. Um, okay, so it's showing here that there's the commit, and then there's the tree. The tree points to this. The commit points to the tree. The tree points to all of this, and we can see all that information um, in this would be a good one. Yes, this would be a good one. So this is, I'm not sure which commit this is. Hold on. It wasn't here. It wasn't here either. What was I reading over here? What is this? This is a commit. This is a oh, wait. This is two different like commits merged. Actually, what does merging look like? Is merging really merging two commits together? Because like I'd imagine that's what replaced the commit here. If there's a parent over here, what are we looking at? 7FF90. I don't see that here. I don't see 7FF90 update readme. Yeah, I'm a bit confused about the hashes that I'm seeing here. This is the hash for the commit. Oh, there it is, 7FF and so and so. I went like a lot more back. Okay. B1F. I kept looking at these three for some reason. I was mainly looking at these three, and I wasn't looking at these, and so I was like very confused about what was going on. But yeah, okay. Anyways, enough diving deep into this. I do want to find out what happens when you merge two branches together. Like what happens in terms of commits, because so far we have seen what it looks like to make a commit, right? We know what happens when we create a commit. We know what happens when we stage a bunch of files. It creates all the blobs, and when you make the commit, that's when it creates when you commit these changes. That's when it creates a tree. Actually, shouldn't it create the tree for staging as well? No, no. The tree is the snapshot. The snapshot should only be created when you are actually committing. Yeah, yeah. Sorry, zoned out. Um, what was I saying? Tree snapshot. Tree is the snapshot. The snapshot only gets created when we commit. And the commit object also only gets created when we commit. So the commit then points to the snapshot, and it also contains a bunch of other information. The snapshot or the tree points to all of the other, files and subtrees if necessary. Okay, so let's continue reading here. A commit and its tree. If you make some changes and commit again in the next commit, not in the next commit, the next commit stores a pointer to the commit that came immediately before it. Sorry, zoned out. Um, right. So what are we looking at here? Commits and their parents. So we have the first thing here. This thing, because it's in okay, temporarily, so you guys can see the diagram. Let's do this. Destroy our eyeballs for a second. So this is the parent commit. This is the first commit. Okay, that's snapshot A. Then we make another commit. Now snapshot A, because it's the very first commit, it doesn't have a parent. Snapshot B, that has a parent, which is basically the previous commit. And then snapshot C also has a parent, which is the previous commit. So snapshot B. I think we are good. So let's go back to this. Okay, a branch in Git is simply a lightweight movable pointer to one of these commits. The default branch name in Git is master. Sorry, zoned out. The default branch name in Git is master. Um, as you start making commits, you're given a master branch that points to the last commit you made. Okay. Every time you commit, the master branch pointer moves forward automatically. Um, okay, note so and so is not a special branch. It is exactly like any other branch. The only reason nearly every repository has one is that the git init command creates it by default and most people don't bother to change it. Okay, right. So I'm guessing this is a tag v 1.0 and then we have master. So that okay, tags is interesting. I've not explored the tags chapter yet. There is a tags chapter. I briefly skimmed through it. I didn't really go too deep into it. I do want to go deep into it because attaching version numbers as tags basically to specific commits would be the git version of doing like a release, quote unquote. um kind of kind of it'll be a way to mark a milestone within the development journey. So if it's a tool and a new version has been released, which has a bunch of features and stuff like that, you can tag it with so and so tag, and then somewhere, I don't know where you would add the information for the tag. I don't know how Git stores the tag information stuff. You can have a separate notepad file or something, txt file, that in which you write down all the information, or you basically write down a change log for that tag. I don't know what functionality, what tools Git gives to edit tag related information, or even if it gives you tools to add any tag related information. But yeah, okay. So head, considering like carrying forward from our previous example, this was snapshot A, this is snapshot B, this is snapshot C, which is why master currently points to this commit, and head points to master. So head is telling us which branch it's currently pointing to, and the branch itself points to a specific commit, which in this case is the latest commit. Okay, creating a new branch. Yeah, I believe I had done the branch creation thing here. Actually, was it here or was it in? It was here. Sorry, it was here. Yeah, we have testing O3. That's a separate branch that I made. First commit from testing O3. Let's check out this branch and see. Okay, we are here. I mean, at this point, if I merge the commit, I don't know. I have to do a diff between them because we have this commit, right? We have sixth commit here, but then over here we are on backup. First commit from here. Sorry, zoned out. Okay. Where was I? Okay, what happens when you create a new branch? Well, doing so creates a new pointer for you to move around. Let's say you want to create a new branch called testing. You do this with git branch with the git branch command. Git branch testing. Okay, okay. Right. I think we can create branches from here as well, right? Yeah, we can. So let's do testing O4. Okay, we are checked out. Um, cool. So now both master and testing point to the same thing. We can test that out as well, right? We have NeoVim here. We have Git UI here. Let's open up Yahtzee here. Let's come here, open Yahtzee. Don't do that. All right. So if we look at refs here, we can see three heads. We have master, testing O3, and testing O4. Now testing O4 and master both point to the same commit, at least currently. And we can also see if we look at head. Oh, also remotes is mentioned here, so there's information about the remote. If we look at head, head is currently pointing to testing O4. Sorry, zoned out. Okay, this creates a new pointer to the same commit you're currently on. Okay, how does Git know what branch you're currently on? It keeps a special pointer called head. Okay, cool, cool, great. So we already know that, which is awesome. Note that this is a lot different from the concept of head in other VCSs. Wait, oh, in other VCSs you may be used to, such as Subversion or CVS. In Git, this is a pointer to the local branch you're currently on. In this case, you're still on master. The Git branch command only created a new branch. It didn't switch to that branch. In our case, it did. In our case, it did. Uh, Actually, sorry, let me clarify. In our case, we have switched. We have checked out the branch. Git branch didn't do that, um, but we created the branch using Git UI, which implicitly also, I'm guessing, checks out the branch. So we have that tiny bit of um, I don't even know what to call it. Tiny bit of luxury there, like tiny bit of convenience there. I don't know. Okay, you can easily see this by running a simple git log command that shows you where the branch pointers are pointing. Let's do that. Um, okay, now I need a CLI or I need a shell. Fine. Git log. Let's do git log one line. One line decorate. Okay, so it shows that testing O4 and master are currently pointing to the same. Oh, there's a difference here though, because in the example that's given, in the documentation, it still hasn't switched. It still hasn't checked out the testing O4 branch. Um, in our case, it's already checked out though, because we did it from Git UI. Um, Git log one line so and so. This is interesting. It's adding. Oh, no, 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 it's not. I was about to say that it's adding a bunch of extra information, but the extra information at the bottom is just more commits. Okay, you can see the master and testing branches are right next to are right there next to the so and so commit. Okay. Switching branches. To switch to an existing branch, you run the git checkout command. Let's switch so and so. Okay, cool, cool. So now head is pointing there. I believe it's also going to mention that while checkout can be used, git switch, I think it's called, that is now the recommended way to switch to a different branch. But we still call it, in Git terminology, we still call it checking out a branch. But it's recommended to use, sorry, it's recommended to use the git switch. I believe it's called git switch. Hold on. Yeah, yeah. Switch between git branches requires git so and so. Okay, all right. Okay. Um, Sorry, zoned out. Okay. Um, Back to this. What is the significance of that? Well, let's do another commit. Okay, let's do another commit. So I guess let's create a new file altogether. Let's do sum o 06. Okay, this file was created. This file has been created in, this file is being created. I'm not sure whether, like, what tends to go with. This file is being created in um, testing o4 branch. So we're going to save that, and then we should be seeing our change here. We'll stage the change and commit the change. So we'll say first commit from testing o4. Added some o6 with some data. Oh, too much. First commit from so-and-so, and then let's come down here. Added some o6 file and added some data to the file. Commit. And now, actually now, if I run, I'm curious about what it's going to look like if I run Siri now. It doesn't show the graphic thing on, like, through Tmux. I'm not getting the graphic thing. But if I run it separately, give me a second. Here, Siri. Okay, to be fair, it still doesn't show that. It does show it for testing o3 though. I guess because I never merged testing o3, and so it had its own thing. There was a divergence there, and it kind of stopped there. Um, yeah, yeah. Okay, so you guys are not missing anything then. Okay, so then also worth noting, we can already see testing o4 is ahead, which, to be fair, we could have seen that in here as well. Testing o4 is now ahead of the master branch. And if we check out the master branch now, our first commit in testing o4 is gone. Okay, this is interesting because now your testing branch has moved forward, but your master branch still points to the commit you were on when you ran git checkout to switch branches. Let's switch back to the master branch. Okay, done. Git log doesn't show all branches at the same time. If you were to run git log right now, you might wonder where the testing branch you just created went, as it would not appear in the output. The branch hasn't disappeared. Git just doesn't know that you're interested in the branch, and it's trying to show you what it thinks you're interested in. In other words, by default, git log will only show commit history below the branch you've checked out. To show commit history for the desired branch. Wait, back up. By default, git log will only show commit history below the branch you've checked out. Okay, that explains it. That explains it. Because master is behind testing 04, so we see everything behind master. We don't see anything in front of master, which so far it's only testing 04. To show commit history for the desired branch, you have to explicitly specify git log so and so. To show all the branches, add the all flag. Is there an all flag here? Actually, that wouldn't work out because this is meant to show a specific branch, right? Not all. I mean, to be fair, for all, I could just open up Siri and see everything there. Yeah, yeah. Um, Give me a second. Okay. All right. So, head moves when you check out. That command did two things. You know what? Let's enter the command. Git log all. Might as well do one line and decorate, and yeah, that's what we are looking at. If we didn't specify all, we would be looking at this. So it's just one commit missing there because the branch is not being shown. The branch that's ahead of master, which is a currently checked out branch, is not being shown. Sorry, zoned out. Okay, that command did two things. It moved the head pointer back to point to the master branch, and it reverted the files in your working directory back to the snapshot that master points to. Sorry, zoned out. Okay. This command did two things. Okay, and it reverted the file. Oh, wait. This command did two things. It moved the head pointer back to point to the master branch, and it reverted the files in your working directory back to the snapshot that master points to. So if we look in Git UI and check out the files list, we can see some '06 is not present here. If we check out, hold on, if we check out testing '04, now we can see some '06 there. Okay, great. This also means that changes you make from this point forward will diverge from an older version of the project. It essentially rewinds rewinds the work you've done in your testing branch so you can go in a different direction. Okay, note, switching branches changes files in your working directory. It's important to note that when you switch branches in Git, files in your working directory will change. If you switch to an older branch, your working directory will be reverted to look like the last time you committed on that branch. If Git cannot do it cleanly, it won't let you switch at all. So I'm guessing that's when you have like a merge conflict of some sort. Okay. Okay, what's the last thing here? Okay, this is done. Wait, this is done. This is done. Let's make a few changes and commit again. Okay, so this time we are on master, right? So we're gonna make a change to, I don't want to cause a conflict, so I'll make a change to some O. Oh, yeah, get rid of that. Um, okay, making a change from master branch to diverge from testing. Actually, let's not. Okay, to diverge. Okay, and then let's commit the change. This would be our 11th commit. Um, testing divergence. I don't know if I spelled divergence right. Actually, let's hold on. Divergence. Let's spell it like this. Do I have spell check on? No, divergence is wrong here. That's divergence apparently. Okay. All right. Also, get rid of that and that. Testing divergence. Commit. Okay. At this point, we should be seeing. At this point, we should be seeing a branch because we actually. At this point, we should be seeing. Dude, I wish the graphic thing worked, but it doesn't. So I have to find a different way to show you guys. One line, decorate. I think graph is one of the things. Yeah, yeah. Actually, okay, this is great. No, this is great because you can actually see the divergence, even though you can't see the thing that's being shown in Siri, which looks a lot better aesthetically, but you can still see divergence over here. So you can see how our testing '04 branch is there's a divergence from the 10th commit, but then our master branch also has its own divergence from the 10th commit. Okay, now your project history has diverged. See divergent history. Let's open that up and I can look into that later. Um, wait, is that the next chapter? Um, yeah, yeah. I think that that is basically the second chapter. That is basically the same chapter. And this is the line. Yeah, this is literally what I just did. Git log, one line, decorate, graph, all. I added all at the beginning, but more or less the same command. You can see this. You can also see this easily with the git log command. If you run so and so, it'll print out the history of your commits, showing where your branch pointers are and how your history has diverged. Because a branch in Git is actually a simple file that contains the 40 character SHA-1 checksum of the commit it points to, branches are cheap and create branches are cheap to create and destroy. Creating a new branch is as quick and simple as writing 41 bytes to a file. So that's 40 characters in a new line. This is in sharp contrast to the way other VCSs, to the way most older VCS tools branch, which involves copying all the project's files into a second directory. This can take several seconds or even minutes, depending on the size of the project. Whereas in Git, the process is the process is always instantaneous. Also, because we're recording the parents when we commit, finding a proper merge base for merging, finding a proper merge base for merging is automatically done for us and is generally very easy to do. These features help encourage developers to create and use branches often. Let's see why you should do so. Let's see why you should do so. Okay, note, creating a new branch and switching to it creating a new branch and switching to it at the same time, it's typical to create a new branch and want to um, switch to that new branch at the same time. This can be done with this can be done in one operation with git checkout, so and so. Okay. Oh, and here's the git switch thing. From Git version 2.23 onwards, you can use git switch instead of git checkout to switch to an existing branch, create a new branch and switch to it. The C flag stands for create. You can also use the full flag create, or to return to a previously checked out branch using git switch hyphen. All right. Okay. So we are done with this. And there was a thing about, let's see, what was this last thing? These features encourage developers to create and use branches often. Let's see why you should do so. Wait, also because we are recording the parents when we commit, finding a proper merge base for merging is automatically done for us, so and so. Okay, all right. So this is going to be the next chapter. However, um, we're not going to be doing this today. I'm going to be ending the stream here. Um, yeah. I'm going to be ending the stream here. Give me a second. Just a minute here. Okay, I think we'll go over to this person's stream. Planetary scientist. That's interesting. And this person, they've mentioned PyTorch, UNet, VIT, which I think is Vision Transformer, Cycle again. They've mentioned a bunch of different like architectures of neural networks. Um, so I'm interested. We're gonna go. Their settings do not allow a raid. Okay, that sucks. Um, okay, what about this person? Okay, can't do that either. Um, okay, let's. You know what? Um, okay, let's hope this person's thing works and there isn't like. Okay, yeah, let's try this. I have no idea what this person is doing. But we're gonna go hang out at their stream. So that's gonna be it for today's stream. We've made some good progress with branching, and I'm gonna. Oh shit, Zaynar, hello, hello, welcome to the stream. I'm ending again. It's okay. There's always tomorrow. But thank you very much for stopping by. I appreciate it. We're gonna go hang out in another person's stream now and see what they're up to. But yeah, yeah. I hope you guys have a nice day, and I'll see you all next time. Peace.